So you have your scene set up now, all the scenery is on it, and it is moving parallax to the left. So what you really need now is to add your character to the screen. So let's start by adding a layer for the character, and we're going to assign it to a SK node. And this time we're not going to make a new layer for it, we're just going to leave it as an SK node. To get started, I'm just going to import this entity class. The advantage of having an entity class is because I can set up a few things at a high level to manage all of my entities. This might be the player, the bullets he's shooting from his gun, or an enemy, a collectible, just about anything. So how is this really helpful? Well, if you want to find the name of a node, it doesn't matter if it's a SK Sprite node, a SK Label node, or any other type of node. You know that it can definitely have a name property because it is a subclass of a SK node. So in the same way, if you have a function that you want to call with any of your objects that can collide with each other or make contact with each other, then making them all subclasses of entity means that anything you add at an entity level will then be applied to all of those different classes. So at an entity level, you might have a function called destroy. And what this will do is relative to whatever the type of entity it is. So if you're working on a bullet and the bullet collides with something, it might then call the destroy function on the target that it has contacted with. If this is a massive wall, then the destroy function might do nothing. If it is an enemy, then it may inflict a certain amount of damage to the enemy. So let's have a look at this entity class. The first thing you have here is a struct called collider type. Now if you remember back to the videos we did on physics, we were talking about category and bit mask. It wasn't really a neat way to do it where you just had a number to represent each category and each bit mask. So by using a struct, we can then have different types of categories and then assign them to different bit values so that they can handle the collisions a lot more safely and accurately, and you have a proper name for each item. So down here I just have two instance variables. These can be used however you want. I just find it handy sometimes to be able to pass in a entity ID or give it a name, and this allows you to look things up easier. So the convenience init for it has entity position, entity size, and entity ID. So when you create a new entity, these are the properties that it will require. And you can see down here, once it is done assigning these properties, it will then run the build sprite function and then the configure collision body. So as you look down, you can see that you can respond to the game loop here, you can configure the collision body, and even handle the way that this entity collides with other nodes. You have build sprite, so this is the function where you're just going to put everything that sets up your textures, etc. for the sprite. And as I mentioned earlier, a destroy function. So by default, they'll just remove all actions from the entity and then fade out the entity and remove it from the scene. And down here you'll find a function I wrote called prepare animation for dictionary. So what this means is you can pass in a NS dictionary that contains all the animation information for your sprite, whether it repeats or not, and it will pass back a SK action containing the entire animation. So all of your animations are actually SK actions, and you'll get to work with those quite soon. So start off by creating a new Swift file called player. We're going to import SpriteKit as per usual, then create the class, which is called player, and it has the superclass of entity. Now first up, I'm just going to set up the player's basic properties. So the two buttons on your interface that you'll be able to press that control the player will be jump and throw. The movement of the player will be handled automatically. So later when we get to the game loop, whenever jump press down is equal to true, it will do something. Whenever throw press down is equal to true, it will do something. Okay, now I'm just going to throw in some of these animations. They are SK actions. Going to leave a spot here for any sounds related to this node. And I also have a few properties related to the state of this node. So whether it's currently on the ground, if it is jumping, if it is currently throwing, and a few other CG floats down here that we'll use to do calculations later. Okay, so we also need an update function, our configure collision body, and build sprite. So I'm just going to come back up to our game settings, and you'll see that there is this empty dictionary here called game parameters. If I click on it, now there's quite a lot of information we're going to be putting in here, so feel free to copy and paste from the completed project. I'm just going to paste in the player data. Okay, so the player data is an array. So whenever you add a new player, you'll be adding it to this array. What's inside each of these players is a dictionary, and it will contain the player name and then the animations. So if you have a look in one of these animation dictionaries, it has the atlas file name, the frames per second, so that's the speed at which you want the animation to run, and then it has the frames, so I've added about 10 frames per animation. Now there's a reason I've laid it out like this and formatted all of these animations the same like this. It is so it can be passed directly into that prepare animations function straight away with no further work. This is already in the correct format to be used in the prepare animations function. Okay, so the first thing we need to know is which of those characters in the array is the character that was picked by the player. So if the entity ID is not equal to nil, we're going to take the player index and make it equal to the entity ID. Now we're going to start drilling through those items in the game settings. So if let characters equal to the game settings, object for key game parameters, so that's this item here. Next we'll need players, so once again object for key players, and they'll be as an array of NS dictionary. So the character we pick is equal to the selected player index within that character's array we just created. Okay, so now my char is going to be the selected character. Now that we know what animations that character has, you can go ahead and run prepare animation for dictionary on all of those animations within the my char dictionary. So I'm looking each of these up by their key, and then assigning it to my instance variable animations. Okay, so straight away I'm just going to start it with the running animation, set my Z position to 50, and also set this property. Okay, now up in entities I'm just going to change my player ninja to an actual player. So I'm just going to add my layer character as a child of the layer game world node. Now I'll add in the code for my character. So my player ninja is going to be equal to player with this entity position, this size, and this entity ID, which is going to be the ninja index. And I'm going to put my anchor point at the bottom right position. Okay, now in the update player, I'm just going to add player ninja dot update and then pass in the delta time. Now if I come back into the player class, to make it move I'm just going to put position equal position plus CG point, and this will be the delta times 160. So if I build and run, the character will now run across the screen. So that's all good, except there's no gravity. He doesn't actually walk on the ground, he's just floating up in the air. And if he runs into anything, it's not going to stop him from moving. So that's where we come into this configure collision body. And we're going to make the physics body equal to SK physics body. And that's going to be a rectangle of size. And we're also going to put in a center point since we are offsetting the anchor point that this is starting at. Okay, so physics body dot dynamic is going to be equal to true. Allows rotation is going to be false. These next four values I've added just to show you that they are there, but we're not actually going to change any of them for this one. I recommend looking up what each of them do, as you'll find them quite useful in some situations. Affected by gravity, yes. For the category bit mask, we'll assign that to collider type player. So what objects do we want that to collide with? Just walls and destroyable objects. And we want to know when it contacts with collectibles or triggers. So if you build and run again, there's not much to see because the character just falls off screen. So even though I've added physics to our character, because the ground has no physics to tell it that it is a solid object which cannot be passed through, it's not going to be affected. So if I come back into the layer world, we're going to add some physics to the tiles where it is relevant. So this first one, which is a corner piece, is going to make it rectangle of size of the tile. Its category bit mask is going to be wall. Its collision bit mask is going to be enemy, player, destroyable and collectible. So everything will collide with it. It's not going to have a contact bit mask and it's not going to be affected by gravity. Now number two, because it is just a surface and you're only ever going to be contacting with one side of it, I'm using edge from point for the physics body instead of rectangle of size. So edge from point will just make a solid line at the top. This means we'll use a lot less calculations, and also when you use edge from point, it makes it static, so the object can't be pushed around, and everything else will stay the same. So when I build and run that again, our player will now walk along the ground and fall down holes. Now in the game settings, if you turn on show physics and then change your simulator to be iOS simulator, you'll be able to actually see these physics boundaries. Notice how low the frame rate is. On your average Apple device, you won't have any frame rate issues. It's simply because the simulator has a very high overhead and it's working really hard to produce this game right now. So if I was then to apply this physics to all the tiles where it's relevant, and then build and run the application again, you can see plenty of squares and lines in here. And there you go, your game is now very basic physics.